you get two numbers to plug into the equation of motion to find the position function of a moving object. Let's read the problem. An apple is thrown upward from a balcony 30 meters above the street at 35 meters per second. The first number is the initial position, that is 30 meters above the street, and then the second number is the rate, 35 meters per second. What I want you to do first is I want you to use the given numbers, the height and the velocity, to find the position function. So this problem is a little bit different than the application problem we usually solve in calculus. So whenever you see an application problem, you read the problem immediately, and then you expect the problem to give you a function to work with, right? So you get a function, either you take the derivative of that, or you take the integral of that, so on and so forth. But this problem, you get two numbers only. So how do you find the position function? Well, we will be using equation of motion, that is y equals to negative gt squared divided by 2 plus v naught t, and then plus y naught. So some specification, the g is gravity. So gravity, we have one numbers for the meter and one numbers for the feet. That is 9.8 meters per second square, or in feet, that is 32 feet per second square. Now, you might be thinking, all right, so gravity, so I am holding my pen right now. If I let go, the pen falls to the table or to the ground, right? So that therefore the gravity is supposed to be negative. Take a look. I have negative gt squared. So when you plug in the 9.8, you will have a negative gravity in the equation of motion. And then the v naught is the initial velocity, which is 35 meters per second, and then the initial height y naught, that is equals to 30. So let's write the position function. So we have a position function. What is that equal to? That is equals to y equals to, this one, let's just use a colon. So y equals to negative 9.8, and then t squared divided by 2, and then plus the speed, the velocity, 35t, and then plus y naught, so that is equals to 30. So this one is this equation is a position function. How do I know? Because initially, when time is equals to 0, you plug in t equals to 0, the position is equals to 30 meters, so I know that the object is 30 meters above the ground. So for the position function, the unit is in meters, right? And then how do you get the velocity function? From position to velocity, you will have to take derivative. So velocity function, then you will be taking the derivative. So this one, let's just call this a v of t. V stands for velocity, right? So this will be derivative from y to vt. So the derivative of that, so you take the 2 down, then you have a 9.8, right? So you have a 9.8 t, and then plus 35, and then that's it. So this is the velocity function, and then velocity is the rate of change of the position, so the unit is in meters per second. And then how about acceleration? Acceleration is the derivative of velocity, so acceleration function, that is the derivative of velocity, which is equals to, we use a stands for velocity, and then the derivative of the velocity function is easy, that is equals to negative 9.8, and then the unit is in meters per second square. All right, and then this one is derivative. All right, so we just got the position, velocity, and acceleration function. So now we can use these three functions to answer the questions. So the first questions in red, I asked you to find the maximum height and time at that point. So you throw an apple up. So just picture this in your mind. You are standing on a balcony. You throw an apple upward, and then the apple will just go up and then reach to the maximum height and then start falling to the ground, right? So what I am asking is the maximum height. So the maximum height that the apple at that point is how many meters above the ground? and then how many seconds does it take to reach to that maximum height. Now, what I am trying to do in here is, do you see that the position function is a second degree polynomial, and then the leading coefficient is negative 9.8 divided by 2, so it's negative. So that means that the graph of the position function is a parabola, and that is concave down, right? So when you do the graph, you expect to see something like this. So you will get an object. Let's just do that in red. So you will see an object. So this is the apple at its initial position. So you throw the apple up, and then the apple falls, right? And then at this point, we have a maximum. So at this point, we have a maximum. And then for this parabola, how do you describe the slope at that point? You will say that, well, the slope is equals to 0 because this is just like a horizontal tangent. So therefore, we have to set the velocity function equals to 0 and then solve for t, right? So we have to set that the v of t equals to negative 9.8 plus 35. We have to set the first derivative equals to 0 and then solve for t. So I clearly missing a t right over there. So let me just add that back. So let me erase this. And then we will add the t back. So t plus 35, we set that equals to 0 and then solve for x. And then that tells me what t equals when the apple is at its maximum height. What is the time equals to? So you will have a negative 35 divided by negative 9.8, right? So t is equals to negative 35 divided by negative 9.8. What is that equal to? That is equals to approximately equals to 3.57 seconds. And then this is the answer to the first question. So that's seconds of what? You start at time equals to 0 seconds, and it takes 3.57 seconds to reach to the maximum height. So to reach maximum height. Alright, so it takes 3.57 seconds to reach to the maximum height. And then what is the maximum height? What is the maximum height? Can you tell me that? It takes that many seconds. So you have to plug in t equals to 3.57 to where? You are looking for the maximum height. So the maximum height is you are looking for the position, right? So therefore, you have to plug in the 3.57 to the position function. So the maximum height is equals to, so max height is equals to, so you plug it in. So you have negative 9.8 times 3.57 square divided by 2, and then you add 35 times that, 3.57, and then plus 30. So what is that equal to? You clean up this math. So the maximum height, that is 92.50 meters above the ground. So 92.50 meters above the ground. They use street, right? Okay, above the street. Alright, I just answered the red questions. How about the next one? How long did the apple travel in the air? So remember this, you start at the initial position, the apple goes up and then drops to the street. So how long does it take for the apple to travel in this path? Start at 0, go up and then drops to the street. How long does it take? So what happened when the apple hits the street? When the apple is on the street, what is the position? That is how many meters above the street. So when the apple is on the street, at that moment the apple is 0 meter above the street, right? So 0 meter, we are talking about position. Then you will have to set the position function equals to 0, and then you solve for t. All right, let's do that. So let's match the color first. So we have to set the position function, negative 9.8 t squared divided by 2 plus 35t, and then plus 30. This is the position function when the apple is on the street. That is 0 meters above the street. And then this one, let's do the divided by 2. So this is a negative 4.9 t squared plus 35t plus 30 equals to 0. So this one cannot be factored. You can be factored, but it will take a lot of work. So in this case, we will just use a quadratic formula. So quadratic formula. So for quadratic formula, that is t equals to negative b squared, negative b, no square, plus or minus b squared minus 4ac divided by 2a. So this is t equals to negative 35, and then plus or minus 35 squared minus 4 times a, and then times c, and then divided by 2 times a, so 2 times negative 4.9. So this one, using your calculator, you will get a negative and a positive, so t is approximately equals to negative 0.773, and then the other answer is t approximately equals to 7.916 seconds. Which one is the answer? This one is the right answer. And then how about the negative? The negative, we don't need it. Why do we get two different answers? Do you see that this is a second degree? This is a quadratic equation, the negative 4.9 squared. So it is quadratic, so you expect to get a parabola, and then the parabola is concave down. How do I know? Because the leading coefficient is negative, so the parabola is concave down. So there are two x-intercept, one at negative 773 and then 0.773, and then the other one is at 7.9. Another way to find this quickly is you use the decimal graphing app. You graph this negative 4.9t squared plus 35t plus 30, they will show you the parabola. And then the other one is you will have to graph y equals to 0, and then they will tell you the two intersections. One is here and then one is there. All right, so what does that mean? It takes 7.916 seconds to hit the street. So you start at 0. Let's do this one more time. You start at 0, and then it takes how many seconds? It takes 3.57 seconds to reach to the maximum height, and then it will start falling, right? So when the apple hits the street, that is 7.916 seconds. All right, so that is the end of this problem. If you like the way I teach this, give me a thumbs up, a subscribe, and I will meet you all in the next video. Signing out.